Uh, in the last session, we discussed until arithmetic expressions. We'll see an example, health data example, and we'll move on to the next topic. So, we're going to take a word problem and turn it into code. This is one of the most important skills you'll build as a programmer. So reading something in plain English, breaking it into steps, and then writing the right variables and formulas. So let's use a simple health data example. Imagine you want to calculate someone's BIM, which is body mass index. The formula is pen. So the formula is BIM weight in kilograms divided by height in meters multiplied with height again in meters. So in code, this means that we need two variables, weight kg and height something like m. Then we apply it to the formula like double weight kg is equal to, let's take 70, and double height m is equal to, let's say 1.75. Now we're gonna implement the formula. So double BIM equals weight weight kg divided by height let's put here m again multiplied by now we'll print it. System dot out dot println BMI let's plus BMI. Yeah, so if you run this, the BMI prints out as about 22.9, which is a typical health range. You'll notice I've used only double, not int, because BMI is almost always a decimal number. If I used int, I'd use the decimals and result would be inaccurate, and parentheses are critical. Height m multiplied by height m must happen before the division. So you can also like another example would be heart rate estimate. A common example formula is 220 minus age to get the maximum heart rate. So 220 minus age, so age should be an integer, and the max heart rate will be an integer. So yeah, this example can be int because heart rate is always a whole number. So here's where people slip up, which is mixing units. So if weight is in pounds and your height is in inches, but the formula expects kilograms and meters, your number will come out way off. So in real projects, especially in when it comes to games, where we deal with units like pixels, meters, or world coordinates, being consistent with units is everything. So also you need to watch out for integer divisions in formulas. So if you write something like int bmi is equal to weight kg divided by height m multiplied by height m, Java will throw away the decimal part. Suddenly your bmi is an integer, which is basically useless. Yeah, if you're calculating like something like bmi, think about, should the variable be an int or a double? Why? It should be double because bmi isn't a whole number, it's usually has decimals. So when you see a word problem, break it into variables. Make sure your units match. Use the right types, int, double, and apply the formula step by step. That's the skill you'll use over and over again, whether it's a health app, a physics calculation, or even just like tracking a score. So yeah, that's about the example. Next topic is floating point numbers and specific notations. So here we'll talk about floating point numbers in Java. That's a double type, and how we represent really big or really tiny values using specific scientific notation. So let's start with basics. An int can hold whole numbers, but in real world we need decimals all the time. Player speed might be 2.5 units per second, or damage might tick at 1.75 health per frame. So that's where double comes in. So it stores numbers in decimals. So an example, so this is super handy if you're dealing with things like scientific data, or even physics values where numbers are very small. Like for example, 3.5 e minus 2. So this value is 0.035. So don't confuse e with the exponent operator. Java doesn't use let me put the symbol. So yeah, so Java doesn't use this symbol for powers. Instead like 2 3 is this is actually a bitwise operator, not it's not a power, it's not 8. If you need exponents, you'll use math.power, which is let me actually math.power. This is what we use for when you want to assign powers. So yeah, use double whenever you need decimals. Expect tiny rounding errors. Format your output. Don't use is equals to. Actually, let's go back again. second. So let's say an example. Uh, say double speed is equal to 2.5 and double time is equal to 4.0 and double distance is equal to speed multiplied by time, and you print it using double using system.out.println. So that prints uh, 10.0, which makes sense. 2.5 units per second for 4 seconds. So the catch here is doubles are not perfectly precise. They stored in binary under the hood, and not every decimal can be represented exactly. That's why sometimes you need weird surprises like this. System dot out dot println 0.1 plus 0.2. Instead of printing 0.3, it might show like 0.3000004. Not a huge deal for most cases, but if you expect perfection, you'll get tripped up. So how do we handle that? Usually by formatting the output. Java's printf lets you round your decimal like this. Printf, and let's say something like this: result percentile 2f percentile n and 0.1 plus 0.2. So this prints result 0.30, which is nice and clean with 2 decimal places. So don't expect exact equality with doubles. So if you write if x is equal to 0.3, it might fail even when x looks like 0.3. Instead, check if values are close enough within a tiny tolerance. So when why can 0.1 plus 0.2 be slightly off in Java? The answer is because doubles use binary fractions, and some decimals like 0.1 can't be stored exactly. Let's move to specific notation that we discussed before in Java. So this is just a shorthand for writing every large or very small numbers. Instead of writing like 1200, we can write it as 1.6 E3. That literally means 1.2 multiplied by 10 to the power 3. So I can't put the power, but yeah, 10 to the power 3. In the code, double t is equal to 1.2 E3 and system dot out dot println t. This prints 1200, which is 1200 yeah, this is super handy if you're dealing with specific data, and as I mentioned, 3.5 e minus 2 is 0.035. Yeah, so yeah, again, don't use double whenever you use double, use double whenever you need decimals. Expect tiny rounding errors for format your output. Don't use equals for comparing doubles. Check if they're close. Use e notation for really big or small numbers, like 1.2 e3 for 1200. So these are small details, but they'll make your code more reliable, easier to read. You'll try this with the Zybook, so that should be clear. Next is we are covering two small but super important things in Java: comments and whitespace, and how to call methods. So these might not look exciting, but they're the difference between code that's a mess and the code you and your teammates can actually understand. So comments, whitespace. First is comments and whitespace. So comments are little notes you leave in your code that the computer ignores. So in Java you have two options: single line and multi-line block comment. So this is how it looks: multi-line. This is single line. So here's the thing: comments are not there to explain what the code does in super obvious detail. They are there to explain why you're doing something. Let's look at a simple example. Int x is equal to 5 and int y is equal to 10, and let's say int z is equal to x plus y, and then you print system.out.println z. So here it runs fine, but if someone is new to this, this is a simple example, but if you're new, it's painful to read. So you could write something like this in comments: add players bonus points, bonus point to the total score. So you'll notice the difference here. The white spaces, new lines. Like I should have written this first like this. So yeah, so this also runs when you run in a compiler, but it's easy to read if it's structured well with spaces and everything. You'll notice here you'll see the difference: spaces, new lines, indentation makes the code easy on eyes, and the comment explains the purpose, not just the obvious. We don't need to write like comments like add x and y, because that's clear from the code itself, but saying why you're adding them, that's helpful. So if you had a block of code that calculates players' health after taking damage, what's one line comment you could add to explain the purpose of that block? So think like that. And next we have calling methods. So calling methods are just actions that objects or classes can do. You have already seen this in action. The syntax is simple. You take an object, type a dot, and then the method name with parenthesis. If the method needs information, you put that inside the parenthesis. Here's some examples. System dot out dot let's say hello dot two uppercase. This basically prints hello. And the other example, system dot out dot println math dot abs -7. This basically prints 7. So you can also store the result in a variable, which is super common. And the important thing to remember is that many methods return a value. You actually have to use it. So if you just write hello dot two uppercase without printing or storing it, the result disappears, nothing changes. You might be wondering why your code isn't doing what you expect. That's, I think, yeah, comments whitespaces are for humans. They make your code readable, explain why something is there. Methods are objects and classes. They are the actions you call. The values they return are what you actually want to use. That's about comments, calling methods. Next we have constructors, accessors, mutators. So we're going to talk how we actually construct objects in Java and how we work with them using accessors and mutators. First is this is too small. This is better. So first is constructing objects. So far we talked about objects. So objects, things that bundle data and behavior. But now how do we make a new one? So that's where the new keyword comes in. So whenever you write new, you're basically saying create a brand new object in memory. So to do that, Java calls something called a constructor. So a constructor is like a special setup method. It runs when the object is created. So there are two main flavors of constructors: default constructor and a parameterized constructor. So default constructor has no arguments, just makes a blank object, and parameterized constructor takes in values so the object can start with custom data. So let's look at some examples. Let's say string s is equal to new string, let's say hi, and system dot out dot println s basically prints hi. So here I make a lot of mistakes. Here we used new to build a string object. So you don't usually create strings this way, but it's something, it shows what's happening. Another example is scanner. It's scanner sc is equal to new scanner system .in. So this line creates a scanner object. that listens for user input. So we are not using scanner yet in this course, but you'll see it soon. Think about thinking constructors are just regular methods you call later. They are not constructor only run when they say new. After that you work with the objects methods, not the constructor. So what does new actually do? It creates a fresh object in memory and runs its constructor. So that's a simple definition for new. Next is accessors and mutators. So now that we can build objects, how do we actually work with their data? That's where accessors and mutators come in. So accessors are also called as getters, return data from an object. Mutators, which are also called as setters, lets you change that data. So let's make a simple example with a person class. So let's say class person private string name. So this is accessor, which is getter. Public string get name return name, then we close. Now this is now mutator, which is setter, which is public void set name string new name, and name is equal to new name, close. So then we can use it like this. Person p is equal to p is equals to new person, and p dot set name, let's say Alex. Now print it. System dot out dot println p dot get name basically prints Alex. So why not just make the just make the name field public and write p dot name is equal to Alex, because that breaks encapsulation. The whole idea that an object controls its own data with a setter, we could add checks like making sure the name isn't blank. With getter, we control what's returned. So skipping getters and setters and just exposing fields directly, that works for tiny demos, but in real code it leads to bugs and data you can't control. Why use a setter instead of just changing the field directly? So the object can enforce rules and keep its data valid. So remember, new calls a constructor which builds and sets up a fresh object. Accessors and mutators are safe way to read and change an object's data. Encapsulation means the object protects itself and you interact with it in controlled ways. So that's about constructing objects and debugging. Okay. So next we have we're going to talk about two survival skills for programmers: reading API documentation and debugging. These might sound a little less exciting than writing code, but honestly, they are what separate people who can push through problems from those who get stuck. Uh, so first, API docs. So API stands for Application Programming Interface. In simple words, it's just an official guide to all the tools Java gives you. So every class, every method, it's all documented. So like let's take a string class. So if you google Java string API, you'll land on Oracle's documentation. It looks dense at first, but let's discuss how to read it. So for method name and signature, basically shows you the name, the parameter it expects and return, and type it returns. And when you go to return type area, it tells you what you'll get back. For example, length returns an int, while substring int begin index or int end index returns a string. So things like that. And when it comes to parameters section, don't skim these, they matter. If you call substring 2,5, does it include character at position 5? No, it stops right before it. So details like that save you a ton of confusion. There are examples in the documentation. Many docs have sample code at the bottom. Those are gold when you're learning new method. Skimming and guessing, you don't want to do that. Where do you find out whether the end index is? So basically, don't assume you know how a method works. Always double check the parameters and return type. And if you're like, for example, if you're looking for a substring, where do you find out whether the end index is included? So that will be in the API documents. So that's the official source. Now let's talk a little bit about debugging. So debugging is just the art of figuring out why your program isn't doing what you thought it would. So there are three big steps. First step is reproduce, isolate, and inspect. Reproduce is basically making sure you can make the bug happen consistently. So and isolate, find the smallest piece of code where the bug lives. And inspect, look at variables, print values, or step through the code to see what's happening. Let's see a classic example, bug, which is an off by one error in a loop. So let's write a for loop. Int I is equal to 0, int 10 I plus plus, and then we print it, system.print.out.println I is equal to plus I. So this prints I from 0 to 9. That's 10 numbers. But if you expect it to hit 10, you'll be confused. So what do we do? Print the variable. So printing I each iteration makes it crystal clear what's happening. So in the real IDE, you'd use a debugger, set a breakpoint, and then set line by line, watching I change. So don't try to fix 5 things at once. Change one thing, test again, see if it worked. That's how you keep control instead of spiraling. So in that loop, what variable would you print to confirm it really runs 10 times? The answer is I. Just watch I go up each step, and you'll be able to. So that's how you see. That's how you debug. So learn to trust the API documentation. They tell you exactly how methods behave. No guessing. When debugging, slow down, reproduce, isolate, inspect, print variables, or step with the debugger. Fix one thing at a time. These are habits you'll use every single week in this course. So for as long as you write code, you will be using that. So the last topic for today is the style guidelines. So we're gonna talk about style guidelines in Java. So now style, okay. So now style doesn't change how computers run your code. It's for humans. Clean, consistent code is way easier to read, debug, and share with teammates. So let's start with few big areas. First is naming. So names matter. Variables like total score, player health, tell you what they're holding. Names like P, X1 don't. When you come back to your code in a week, or if you're working on a team, you want names that make sense instantly. So use camel case. I think I mentioned in previously the camel case for variables and methods, for uppercase for constant like max speed, all caps. And next we have indentation. So always indent code inside braces. So it's like putting visual brackets around chunks of logic. So if you skip indentation, your code turns into a wall of text. That's something you don't want. Braces. So brace style in Java, a common style is to put opening braces at the end of the line, like something like this. Yeah, this is an example, like this. Yeah, that's the style you'll see in most textbooks and professional code bases. And line length. So keep lines short. If a line runs off the screen, it's a pain to read. So break it up, indent the continuation, keep things tidy. Consistent formatting. So pick one style and stick with it. Mixing styles is worse than having a simple one. So most IDEs and even some text editors have a auto formatter. Run it and it will clean things for you. It's like spell check for your code's layout. So using random or inconsistent names can confuse everyone. So living in magic numbers like just 42 instead of giving them a constant name. So if you have variables named P, Q, what would you rename them to so they actually make sense? So that style is better. So style is about making your code friendly for humans. Computers will run messy code just fine, but you and your teammates won't want to read it. Stick to clear names, proper indentation, consistent braces, formatting tools. That's the end of this chapter.